Assalamualaikum, my name is Muhammad Shazwan and I will explain about the scenario of the problems. For the first point, high usage of raw materials, which is limestone and shale. The use of a huge amount of natural raw materials for the production of cement has also resulted in over-exploitation of the natural reserves of natural resources and a corresponding deterioration of the environment aesthetic and alteration on ecosystem. Various waste materials generated by various industries can be utilized as sustainable alternatives to the conventional materials used in the production of cement. Hence, the use of such waste in the production of a sustainable alternative for cement would result in a significant reduction in the greenhouse gas emission cost and consumption of natural raw materials associated with cement. For the next point is global issue of carbon emission. The production of ordinary Portland cement, which is OPC, is the second highest contributor to greenhouse gas carbon dioxide emission pollution, which contribute to environmental pollution. According to Alabi and Mahachi 2021, 1 ton of cement production is equivalent to 1 ton of carbon dioxide released into the air. Based on the data that have been provided in World Data Status in Malaysia, there are 262.2 million tons of CO2 emission in Malaysia in 2020. As a result, it is essential that a solution to be found for the extremely worrying problems that have been experienced by the environment in the construction industry. For the third point is nitrous oxide emission. Nitrous oxide emission come from burning gasoline, coal, and other fossil fuels. Ozone is formed when nitrogen oxides and volatile organic compounds mix in sunlight. The volatile organic compounds come from sources ranging from industrial solvents to volatile resins in trees. Ozone that near the ground that can cause a number of health problems such as asthma attack, sore throat, clogging, and other health difficulties. In addition, nitrous oxide, carbon dioxide, and methane are the most important greenhouse gases.
What is geopolymer concrete? Geopolymers are in the family of mineral polymers in which their chemical combination are similar to zeolite materials, whereas their macroscopic structure is amorphous rather than crystalline. The use of polymers such as concrete adhesives result in the production of geopolymer concrete that can be suitable substitute for OPC or it known as ordinary Portland cement. Geopolymer was the name given by Didovitz in 1978. Two materials which are characterized by chains or network or inorganic molecules. Geopolymer cement concrete is made from utilization of waste material such as fly ash and ground granulated blast furnace slag (GGBS). Fly ash is the waste product generated from the thermal power plant, and the ground granulated blast furnace slag is generated as waste material in steel plant. The main constituent of geopolymer source of silicon and aluminium, which are provided by thermally activated natural material or industrial byproduct. Alkali activating solution which polymerize this material into molecular chains and network to create a hardened binder. It also called as alkali activated cement or inorganic polymer cement. There are 5 materials required to produce this concrete. The first one is fly ash, a byproduct of thermal power plant. The second one is GGBS, a byproduct of steel plant. The third one is fine aggregate. The fourth one is coarse aggregate, and the last one is alkaline activator. It is a combination of solution of alkali silicates and hydroxide. The role of alkaline activator solution is to activate the geopolymeric source material containing silicon and aluminium such as fly ash and GGBS. Next is about the properties of geopolymer concrete. The mechanical properties. The compressive strength of geopolymer concrete have been found up to 70 megapascal. The concrete gains its compressive strength and rapidly and faster than ordinary Portland cement concrete. The concrete strength after 24 hours have been found to be more than 25 megapascal. The other properties are the drawing shrinkage of is much less compared to cement concrete. This makes it well suited for thick and heavily restrained concrete structural members. Second one, it has low of hydration in comparison with cement concrete. The last one, the fire resistance is considerably better than OPC based concrete.
Next, on the justification on the proposed solution. Firstly, it will help in reducing the carbon footprint produced. Conventional concrete produces huge amount of carbon dioxide towards surrounding. By implementing geopolymer concrete, we can reduce the carbon dioxide emission by a lot, and it will help in reducing the carbon footprints that are usually released by the concrete structure. Second is the usage of pozzolanic material to save costs and raw materials. By using geopolymer, we will reduce the usage of the raw materials that will be used, such as cement, by replacing it with pozzolanic materials. The cement will be replaced with the pozzolanic material that is usually produced from waste products such as agricultural waste and also product of coal power plant. This will help in cutting the cost of raw materials. Third one is it also can create concrete with high resistivity toward extreme environment. By using geopolymer concrete, the concrete will have a better resistance toward extreme environment. Geopolymer concrete that use pozzolanic materials such as fly ash will offer better chloride resistance rather than conventional concrete, which will be useful on an environment with severe chloride attack such as seawater. Implementing geopolymer concrete structure at extreme environment will have greater lifespan than conventional concrete.
As for the conclusion, cement production is a major source of carbon dioxide. But concrete is a desirable construction material, having low embodied energy, high thermal mass, potentially high durability. So, the task confronting us is to minimize the usage of cement without reducing the production of concrete, and, if possible, with minimum disruption of the cement industry. Geopolymer concrete is well known for its promising mechanical properties, acid resistance and fire resistance, and therefore is a potential alternative construction material with comparable properties to OPC concrete. The constituent of geopolymer concrete shall be capable of being mixed with a relatively low alkali activating solution and must be curable in a reasonable time under ambient conditions. Geopolymers emit approximately 80% less carbon dioxide than OPC during production, making it a more environmental friendly building material. Like OPC concrete, geopolymer concrete has a brittle failure. Alternatively, fibers can be added to improve the ductility of concrete. The properties of geopolymer include high early strength, low shrinkage, freeze-thaw resistance, sulfate resistance, and corrosion resistance. These high alkali binders do not generate any alkali aggregate reaction. The geopolymer binder is a low carbon dioxide cementitious material. It does not depend on the calcination of limestone that generates carbon dioxide. This technology can save up to 80% of carbon dioxide emission caused by the cement and aggregate industries. Due to the high early strength, geopolymer concrete shall be effectively used in the precast industries so that huge production is possible in short duration of time.